Hello students, welcome to the next lecture of Boolean algebra. In the last lecture we have done with the SOP and POS. In this lecture we will start with the K-maps using first we will do with 2 inputs, then 3 inputs, then 4 inputs. Now what is K-map? It's a method of simplifying Boolean algebra expression. Now we can see that result from the Boolean algebra is not always minimum. So we have to minimize that expression. For that purpose, we have to use the K-maps. First example, you can see this is the truth table. In this case, you can see we have two inputs, A and B. When we are going to apply the operation on A and B, for example, these are the corresponding outputs with respect to these inputs. What are the inputs? 0, 0, 0, 1, 1, 0 and 1, 1. These are the outputs W, X, Y, Z. Now see, now we will make a K-map for the above truth table. Here is the A, B, 0, 1 means these are the inputs related to A. These are the inputs related to B. Now first 0, 0 will place here, right? 0, 1 will place here. 1, 0 will place here and 1, 1 we will place here. Next, see this is the second example. Prior to moving towards the second example, we have to see how we are going to place it. I'm writing it here itself. A dash B dash. Here is A dash B. Why we are writing dash? Because if there is a 0, then we have to write out in the form of dash. If there is 1, then without dash is there. A, B dash, and here is AB. Now, in our second question, what is the expression we have to place? AB plus A dash B dash. See, so AB means this position and A dash B dash means this position. So that means here will come 1 and here will come 1. Rest all is 0. So see it here. This is the answer, or we can say K-map for the expression. Now this is not reduced. We are just placing it in the K-map. So simplification using K-map. For the simplification purpose, we have to combine together adjacent cells into single terms. There are certain rules for that. First rule, any cell containing a 0 cannot be grouped. For example, we can't group it like that, 0 and 1. This is the wrong grouping. We always groups the ones, for example, in this way or in this way. So we always groups the ones, not with the 0. Second rule, groups must contain even number of cells. See, these are the 3 number of cells for which we are going to make a group, but this is wrong. So always there is the even number of groups. Next rule, groups must be horizontal or vertical but must not be diagonal. Diagonal grouping is not allowed in this case. You can see this is the diagonal grouping. Yes, it is not allowed. See, this is allowed. Yes. Next, this is also allowed. So this is proper vertical grouping. This is proper horizontal grouping. Next, groups must be covered as largely as possible. We can make the one group. This is the insufficient grouping because here we are making the two groups. But this is the proper grouping because we are going to make 4 ones in a single. Next rule, if one of any cell cannot be grouped with any other cell, then it will act as a group itself. You can see it here. So these itself will act as a group. Next rule, groups may overlap but there should be as few groups as possible. So it may be overlapped means this is one group and this is the second group. This may get overlapped but there should be as few groups as possible. So next rule, leftmost cells can be grouped with the rightmost cells and the topmost cell can be grouped with the bottommost cells. See, we can make the group in this way. This is 1 and this is 2. So that means this is the overall one group. So see the next. Now we are moving further with the help of either 2 inputs, then 3 inputs, then 4 inputs. There are 4 cells in the 2 variable K map. See what are the cells? X, Y, that is X dash Y, that is X, Y dash, and that is X dash, Y dash. Now here are the two inputs. 0 0 combinations are 0 1 1 0 and 1 1. So these are the outputs corresponding to that, and this is the location on map. See, a general representation of a two variable K map plot is shown below. Now this is the zeroth number, this is 1, this is 2, this is 3. Same way we are going to place these things. So this is the general representation, we can say that. Now earlier in the last video we have studied two things, that is SOP and POS, sum of product and product of sum. So sum of products are represented always in this form A bar into B bar, A bar into B, A into B bar, AB. But product of sum is always represented in this form A plus B bar, A bar plus B, A bar plus B bar. So we have the question either in both forms, SOP or POS, depending on the statement. Now simplify the given two variable Boolean equation by using K-map. See, these two are the inputs. This is the output of this table. So at how many positions we are getting 1? So this is the positions. This is X dash Y. This is X, Y dash. This is X and Y. So that means at which position it should be 1? X dash Y. I think so this is X dash Y, and this is X Y dash, and this is X Y. So how we are going to make it a combination? For this purpose we have studied the rules. So this is the one correct combination and this is the second correct combination. Now see the common parts. After grouping the variable, our next step is to determine the minimized expression. So for this purpose our expression is X dash. For this purpose our expression is Y dash. So the reduced equation will be X dash plus Y dash. This is the answer of this truth table, minimized expression of this question. Next, three variable K maps. For a three variable Boolean function, there is a possibility of 8 output minimum terms. General representation is this one, you can see it here. So these are the output functions. Now see how we are going to represent it in the K map. Now see A, and there are two inputs, that is BC. So the combinations are 0 0 0 1, and next value should be 1 0 and 1 1. But the point is that we can change only one input at a time. So that means if we are changing 0 1 with 1 0, so that means we are changing the two positions. That is not okay, right? We can change only one variable. So that means that is in place of 0, what's the value will come here? 1. And next is 1 and then 1 0. Now the values in between also get changed. 0 1, there is 2, there is 3, next is 4 5 6 and 7, and these are 0 1. Now it is using SOP form and POS form, that is 3 variable. So either we can take two variables on this side, or in this side. So same concept is there, that is A, and A bar is 0, A is 1, 0 0 0 1 1 1 1 0. So same way for this. For the POS form, same thing is there, A, B plus C, A plus B plus C, A plus B plus C bar, because for the 0, no need of bar in the case of POS form, that we have studied earlier in my last video. So in this way we can plot it, the general maps using SOP and POS form. Now next is the example. So simplify the given 3 variable Boolean function by using K-map. See the question. X dash, these three are the inputs and this is the output of this function. So in this case, at which position 1 is coming? 1, 2, 3, 4 and 5. So see, that is x dash, y dash, z dash. Yes, it is the first term. Next is x dash, y dash, z. That is the second term. Same way the next terms are there. Now our target is to place this into this K-map. So see here, this is M0, M1, M2 until M7. Or we can always say that 1, 2, 3, 4, 5, 6, 7 or 8. Or you can also start it from 0 also. Same concept is there, nothing can be changed. This is 1, this is 2, this is 3 and this is 4. And after that this is 5, this is 6, this is 7, this is 8. If you are going to start it from 0, then the ending value is 7. So you can start it here also from the 0 instead of 1. So now the point is that at which position we have to place the 1? First position, then second position, then at third position, yes, then at fifth position, then at eighth position. Now how we have to make the pairs? First pair is this one, right? Second pair is this one. Third one is the single one pair and fourth one is the this one pair. Now see the minimized expression. So the minimized expression is xyz plus x dash z dash plus x dash y dash plus y dash z dash. Next is 4 variable K-maps. There are 16 possible minimum terms in case of a 4 variable Boolean functions. So for the 4 variable combinations are total 16 and these are the output functions. This is the K-map location starting from, if it is starting from 0, the ending value is 15. Now a typical K-map is shown here. You can see it 0, 1. Here same concept, we can change only one value at a time, so that's why it is 3. And same way here also 3, after that 4, 5, here is 6, here is 7, then next 8, 9, 10, 11, next is 12, 13, 14 and 15. Now next is using soft form as well as post form. If we are using the soft form, then the product is there. If we are using the post form, then sum is there. See the example. Now in the example, simplify the given 4 variable Boolean equation by using K-map. So at which position we have to place the 1, 5, 12, 13. So just see it here. What it is saying, 1 means this position, 5, 12 and 13. So these 4 position will be 1, rest all is 0. Yes, it is okay. Now by preparing K-map, we can minimize the given Boolean equation. First we will make this pair and this is the second pair. This one and this one. Now just write out the reduced equation. What is the reduced equation? W y dash z plus W dash y dash z. So that's what about this K-map. Thank you very much. In the next lecture, we will start with the graph theory.